All right, guys. How are you all doing?
Well,
You don't like Calc 2? Yeah, Unit 1, 2, and I don't remember what 3 was, are really weird because they involve all this vectors and stuff. But then it goes to other topics. And then Calc 2 really jumps from topic to topic. It's not like Calc 1 where it's not like Calc 1 where everything was continuous. You just do many different things. And my friend in the math department learned this stuff in Calc 3. So there's that. So, okay. How did the exam go last semester? It was bad? Or it just, I don't know the average. Most students find Calc 2 the toughest, but I did worse on Calc 3. That's just because I got lazy, but it's like the summer. Okay. So so the sign-in sheet is passing around. Make sure you guys sign it. And do you guys have any questions? Just directly? Anything about anything like speed school, waffle? No? Okay. So you guys all know how to find the magnitude of a vector, the direction and everything. You learned that in Calc 1. The equation of a sphere. So essentially, you guys should know this very well. You've done enough problems, and it's not that complicated. The sort of problems that you might have on the exam, we'll be getting to it. So we can start with this problem. Yeah, it's a sphere. Can you guys all see this? Yeah. So objective 2 is to find the center and the radius of the sphere. So you have to turn this into an equation like the top, and you do that by completing the square. So we can look at this x squared plus 4x. What would we add to it to make it a square? Plus 4. So we have to remember that. We have y squared minus 2y. What can we add or subtract? 1. You guys all remember how to do that? Completing a square? Okay. And then with z, so we have 6z here. What do we add? Yeah. B squared plus 6z plus 9. Okay. And whatever we do to that side, we have to do to the right side. So we have 11 plus 4 plus 1 plus 9. Okay. We rewrite it as x plus 2 squared plus y minus 1. squared plus z plus 3 squared. That's equal to 25. Okay. So what would our center coordinates be? Yep, -2, 1, and -3. Okay. And what would our radius be? 5. That should be really basic, right? And you guys know midpoints, I'm sure. I'm just going to raise it. It wasn't, or yeah. So if you didn't copy it down, just ask someone, but it wasn't that tough. So if we have x squared plus y squared plus z squared less than or equal to 25, you guys should be able to draw it, okay? I need to say z is greater than or equal to 0. Okay? So what does it mean? Right? So what shape will it be? The top of a sphere. Something like that. What does the equal sign mean? It includes the top boundary. And then this z is greater than 0 means it's the top half. If I just gave you this figure, and I told you guys that the radius was 4, you guys should be able to write this out. Yes? No, it'd be 16, but you would be able to go it backwards. And then in this, the center is 0, 0, 0. The center could change as well. But they probably will not test you on that. They might throw it in, but the practice exam that we'll do on Monday night doesn't have that. You should understand it though, because it'd be easy points that you would lose if you don't know. Does anyone want to say the scalar projecting those two equations that you know, the comp of A to with respect to B? Divided by? It depends on what you said, but it'd be B because it's yeah. And then what would the projection be? Okay. So it depends on which one you're doing it with, but all right. They did A. Okay. You guys all remember this stuff? There's an entire problem on it in the old exam, so they'll test you guys on it. So this is A dotted with B, or the magnitude of B. Okay. The projection is different because now we add directionality, and that's the direction of B. Okay. Make sure everyone signs on the paper. So that's all review stuff right now. And let me know if you guys have any questions. Just back there. So who hasn't signed? Raise your hand. So, yeah, you can. You guys can pass that back, and I'll give one more paper. Yeah.
How does like the terminology for that? Is that the component of B on the A or the C on the B?
This is A onto B, I believe. Let me look on this. Yeah. It would be A onto B. Yeah. And then, so you guys did this problem last year. You know how you have to find vector B1, vector B2, and then vector B, something like that?
Yeah.
Yeah. So there's a problem like that same problem on this old exam. So you'll have something like that on the new exam. Okay. Like, do you guys get what I'm talking about? Yeah, like finding vector B2 when you're given when you have to find vector B1 and vector B. Just I'll tell it again on Monday night. So any questions on this right now? No? Okay. Let's do a cross product. Do you guys all understand cross products at this point? Yes? Like V1 cross with V2. Okay. So this would be AI plus, let me use numbers. I plus J plus K. So it's ones dotted with 2I plus 2J plus 2K. So then we set it up. Make sure you guys understand this and don't make any algebra mistakes because you do this over and over till the end of calculus and stuff. Okay? Yeah. In these problems, you're using it to find the normal vector. But it's used to find the vector perpendicular to your two vectors. And other stuff, but I even haven't learned that yet. Okay. That's in linear and I haven't taken. So. The first part is you leave I, you multiply across like that. So it's 2 minus 2. Okay. So the top left minus the bottom right, or times the bottom right. You guys get me? Minus J. A lot of people forget to subtract J, so don't forget that. So then we sort of block out J, multiply the diagonals with them. So that's 2 minus 2 plus K. What would K be? Yeah. That's a good question. And I'm sure there's a proof to that. Is it in the slides? You can ask Dr. Tyler that. He'll give you a long answer. You pretend to understand it, and then he'll be impressed. So, this problem, what answer do we get overall? Yeah, so it's not 0. It's 0i plus 0j plus 0k. Yeah.
Which one do we like? Which one's first?
So the top left times the bottom right, minus the other one. Yeah.
Could we just write like 0 vectors at the same thing, or is that something different?
Like that?
Yeah.
No, don't do that.
What is that?
I don't know what that is. That means it's like 0 with parallel lines or something. There's actually something that I'll show you where you do get that answer.
Okay.
In like a few minutes. But for this, it'd be 0i plus 0j plus 0k. Okay?
So even if there's a 0i or 0j, we should still write that out. We shouldn't just like say like.
Yeah. You won't have a problem like this,
Yeah.
because obviously I just made it up and it's 0. But say you have 0k and then you have I and j components.
Yeah.
You don't need to write out the k component. Yeah. Yeah. It's 0. So. Yeah. Okay. Now the magnitude of this would be what? So we'll just call it n. The magnitude of n would be what? It'd be 0. This has no directionality. Okay? You guys understand that difference? So if you just put 0 without I or j, it'd be wrong. All right, this is just something that you guys will have to remember. The area of a parallelogram is equal to the magnitude of the n vector, okay? Area of a triangle will be what? 1/2. And then there's that really big shape. Let me find that formula. I don't have it. I'm just telling you guys this because they could put in like a 2 or 3 point question that's very simple. You just have to do the formula. But if you forget it, then you can't do it. Yeah. Yeah, okay. Volume of a parallelepiped. Parallelepiped. Some. Okay. The volume of that, I think they gave us this one in my exam. A cross with B dotted with C. Yeah.
Is that commutative? Does it matter? Say C cross B dotted A, can be the same thing, or is that?
When you do a cross product and you do, okay, this isn't what you're asking, but when you do B cross with A, you get a negative answer. So that's wrong. But if you do A cross with C plus B cross with C or something, it might work.
I'll say if you like mix up the order, it's like B cross with C dotted A, not A.
Yeah, it would depend on that. So And I would say right now that it shouldn't matter, but don't take my word on it. Okay? And I'm sure they'll be very clear on which one is which. Yeah. Any questions on this? Yeah. The parallelepiped. It's like the parallelogram slanted in 3D. Something like that. Okay. I'm gonna erase it now. Okay, so this stuff that I'm about to go through, they tested us on it, but on your old exam, it doesn't show it. They could still test you on it on this exam, so I'm gonna cover it. Okay, so this will be on the second exam, definitely. Like not next week, the week after. What does A cross with vector A equal? A vector. So it'll be some problems like this. A vector multiplied by a vector. Did they go through this in class? Yeah, I'll go through the weird cases. A dotted with B. A dotted with A. 0. A crossed with A. 0 vector. Remember that a dot product always gives you a scalar. A cross product gives you a vector. Okay? Yeah. Yeah, 0 with the arrow on top. A vector dotted with B, which is not a vector. Undefined. And A vector crossed with B, that's not a vector, is what? Undefined. So don't forget those. Remember, scalar component multiplied by a vector is still a vector. A vector dotted with a vector is a scalar. And a vector crossed with a vector is what? A vector still. So I'll do practice problems with those. Yeah. Are you talking about this one?
Yes.
It would be in class they did what? This are you saying is equal to a 0? This right here? I've never. Did she do it in class? Did she do it in class? Because they never showed that to us equal to a 0i, 0j. Yeah, just write the 0. Let's do some problems with this. What would that be?
So, vector, and then you cross it.
This here is a vector. This is a vector. You cross them, you get a vector. You cross these, you still get a vector. That's how the problems on your exam will be. Any questions on this? Yeah. So this is like a coefficient in front of the vector, the little a. So it still remains a vector. Same thing here, the little b times the vector b, it remains a vector. When you cross two vectors, you still get a vector.
Yeah.
And again, when you cross two vectors, you still get a vector. Yeah, there's like many different combinations. We'll go through them. Yeah. Yeah.
So are they just gonna like want us to identify the vector?
Yeah.
They're gonna use like actual like coefficients?
No, there won't be coefficients. It'll either be vector, scalar, undefined, 0 with the line, or 0. So we have A with big A dotted with B with big B. That's with C. C on top.
That's undefined.
Okay. How many of you think it's a vector? Mainly this side. And you, the round one. Okay. How many of you think it's a scalar? Okay. Why do you guys think it's a scalar?
A, O A times vector A just gives you a vector. And then O B times O B gives you another vector. Vector dot the vector is a scalar. Scalar times on the right.
This is a vector. Scalar times a vector is what? A vector. This scalar is just like a coefficient being multiplied to it. Okay? So it is a vector. Any questions on this? Do you guys all understand this problem?
Yeah.
I'll say it again. This A is like a little number multiplying to the vector, okay? But A is also technically a scalar, okay? So a scalar times a vector remains a vector. Same thing for all these two. A vector dotted with a vector always gives a scalar component, okay? A scalar component being multiplied with a vector is just like multiplying 5 times a vector, okay? So it remains a vector. Okay, let's do another one. What is this? It's a scalar. Who wants to explain it? Let's call on a random person. Okay, you can do it.
So the constant times vector is vector, and then scale is vector. then you cross them so you get a vector. And then the other one's also a vector, you got it, and it makes a table.
Did you guys follow that? I won't get into other problems. I'll do one more. This one. Okay. Which vector?
Oh, no. Wait.
Yeah.
You have numbers.
Okay. This remains a vector. Okay. These are all scalar components. We'll just call it an S with a B vector. Okay. They're the same vectors, so they're parallel. And so it'd be like zero vector. Cross product of the same vector is 0, and it's a scalar component, so it's 0 parallel.
It doesn't matter if you multiply these.
No, I could multiply by whatever here. Yeah, because this is still a B vector crossed with a B vector. So it's like this is a B vector, and then I multiply a copy of it by 5. So I have 5 B vector up here. Or it'd be actually like bad or something.
Why is the first quantity considered a scalar with the B vector? Wouldn't it just be like a constant? Like the
Yeah,
AC just be
a scalar is a constant.
Okay.
Since a scalar is just a number, it's a constant. Constant is a scalar.
Okay. But why wouldn't it just be like A, B, C, B vector, and that whole thing just be like a vector?
Yeah, I just called it S, because
Okay.
technically it'd be A, B, C, or whatever
Okay, but
order.
since they're both B vectors, that's why it's 0.
Yeah.
It doesn't matter if there's constants.
Yeah. So we'll do more problems like this when you get to an exam with them. So I covered this because they could put it on this exam, but the chances are very unlikely because the old exam he gave me doesn't have this. Okay? So if you have any questions on it during like Monday session, you can ask me that. Any questions right now? Okay. Equation of a plane. Does anyone want to say it? Or, wait, let's do this. Let's do someone wrote Chris here without a last name.
Yeah.
Do you want to say the equation of a plane? What? It did say first name. Technically, I'm not allowed to turn this in now because it was last names. But because before they could do that, but starting last year, because it gives away like your entire name with their ID, so it's too much information. Something like that. Okay. The equation of a plane. You can do it if you want.
Oh yeah. It's A plus B.
Yeah.
2y minus plus C. Z minus equals 0.
Yep. So you guys definitely should know this by the exam. This A, B, and C are very important because you get them from your normal vector, which is AI plus BJ plus C. Okay. Okay. So now we get to those problems. Objective 16 is finding the acute angle. Do you guys remember that formula? I'll just quickly write it, but yeah. Who wants to say it? So yeah, you can do it with AB, or you can do it your first normal dotted with your second normal with the magnitudes of n1 and n2. So you would have two normals. Okay? Because it's the acute angle between two planes, and each plane would have its own normal angle. There's a problem in Dino that goes over this. You guys can look at it. Equation of a line. It's very important that you guys know that, like, this is the form that you write an equation of a line in. So I'll just write xo plus at y naught plus bt, and then v naught plus ct. Okay, so whenever it asks you for equation of a line, you give all three of those. Okay. So now I'll just, any questions on this right now? No? Okay. Yeah?
What information do you usually start with, or is there like a bunch of different options of information?
There's a bunch of different options, and it goes by problem. Most problems, you find normal with the cross product, you convert it to a plane, but then they did that problem with distance, where the normal is the line, okay? So you just have to look at the problem. And then there's like 3-4 different kinds. We'll go through them right now. I don't need to explain how to find distance like P1 to P2, and then you use, okay. So if I did give you P1 to P2 and said that's A I plus BJ plus CK, okay? You would know that this A is equal to this A, all right? Same thing for B and C. And if a point on P1 was x comma y comma z, or x naught, y naught, z naught, those would equal that, okay? You could use the points from P2 or P1 for the x values, x, y, and z. That's how you get to them. When do you guys normally have your homework due? Monday? Okay. So you guys should know by now. You should have it done over the weekend, like always, right? Right. Because then you can study on Monday night for the exam. Okay. I never really study from the homework. So we'll do objective 18. That's finding the equation of the line of intersection of two non-parallel planes. Okay. Make sure you guys sign in and stuff. Okay. So for one plane, we have 2x. So this is the problem that you guys did in class. Is that okay if I go through that problem? Okay. Plus 2y, right? Yeah, minus 2z equal to 5. 3x minus 6y minus 2z equal to 7. Okay? You have two equations of non-parallel planes and you have to find the line of intersection. Okay? So you're given two planes. Automatically, your first thought should go where? Make them vectors. What vectors? What vector gives us A, B, and C for the equation of planes? The normal vector. Okay? So right here, we have some information. N1 is going to be 2I plus j minus 2k. Okay? When you have an equation of a plane, remember it connects directly to normal vectors. All right? The coefficient in front of x, y, and z will always correspond to a, b, and c in the equation for a normal vector. So who can tell me the equation for N2? 3i minus 6j minus 2k. Okay? Make sure you get that connection. And then you have two vectors here. Okay? What does a cross product allows you to do? Find something perpendicular to two vectors. Okay? They can be any vectors. They don't have to be normal vectors. In this case, we had two planes. We found the normal vector, which is perpendicular to those planes. Okay? If we find what's perpendicular to the normal vectors, we go back to the original planes. Okay? And the line that we'll get will be parallel to the line of intersection. Okay, let me draw this quickly. You have two planes here, right? Okay? They're crossing each other right here. Okay? Normal vector allows you to find perpendicular. Okay? And 1 and 2. Yeah.
Like the coefficient, shouldn't that give you a parallel? The coefficient of the plane, like the.
No. when the equation of a plane comes from the normal vector,
Yeah.
which is always perpendicular. Okay? So now we have two vectors, and when we do the cross product of them, we get something perpendicular to those two vectors. Okay? So a line, I don't have a different color. Okay. This here will be perpendicular to those two. Okay? These two are already perpendicular to the plane. So this vector which forms is parallel with the line of intersection. Okay? Thanks. It's in Dino. Yeah. Did you guys follow that? So the line equation that we get will be a line parallel. And then let's find that right now. So that vector is equal to the cross product of them. So I'll just do that. Okay? So then we have 2, 1, minus 2. 3 minus 6 minus 2. Okay? Okay. You block these two out. Minus 2 minus a negative 12. So you get minus 14i. These are, you're subtracting a negative, okay? So this would be minus 2 minus a negative 12. So, wait, it should be.
No.
So yeah, it'd be positive here. Okay? Negative 2 minus a positive 12 gives you negative 14i. And you get minus 2j minus 15k. So you guys, in your mind, should try to figure those out. Make sure you get negative 2 and negative 15. Are we good?
What was that asking us to find?
We're trying to find the line of intersection. This now here is parallel to the line of intersection. Okay? Any questions?
So, it means we just have something parallel to the line of intersection.
Yeah. No, we're not done yet. Yeah. Now we need to find any point on the intersection line. Okay? Originally, we were given the equation for the planes, right? So you could do this with either x, y, or z, but in this problem, the way they do it, we set y is equal to 0. Okay? In order to simplify it. So then we are left with 2x minus 2z equal to 5. This is saying that if we were to look at a plane over here and assume we're at the point where y is equal to 0, that would be the equation of the plane. Okay? If we're in the coordinate system where y is equal to 0, this would be the equation of the plane. And the top equation would be 3x minus 2z equal to 7. Okay? So we're subtracting that in order to simplify, find x and z.
Plus one inside of that bottom one. What's pretty negative?
Because it's minus 2z originally and minus 2z.
Why do you have a negative from?
I'm multiplying it by, Well, I'm subtracting them.
Oh, okay.
Yeah. So I don't want to write below here, but I'll put an arrow. So when we subtract them, we get minus x equal to a minus 2. So x is equal to a 2. If you plug that back in, z is equal to negative 1/2. Okay? Yeah.
Where did you get the y equals 0?
I decided we were at the point y is equal to 0. You could decide technically any point, but then it's best to decide one of them to be 0, because then you can simplify them. Because if you decided y is equal to 1, you have 3 variables still and 2 equations. So then the point, so this is now like a random point on the plane. We'll call it p naught 2, 0, negative 1/2. Okay? Do you guys have this copied down? No.
Then you get to the point intersect, right?
Yeah. That's any point on the line of intersection. Yeah. So now we have a point and a vector equation. Okay? What are the 2 things that an equation of a line consists of? X is equal to what? Yeah. So a point and a part of a vector. A direction of the vector in that plane. So I will erase this. So x is equal to x naught plus at. Okay? So we have x. We found a point on the line of intersection. 2 plus, what will a be? Negative 14. So for y, we'll have 0 for the y naught, minus 2t for that component, and z is equal to minus 1/2 minus 15t. Now, did that make sense to you guys? How there's little components to each part. Like 2, 0, minus 1/2 are a point on that line that we found. This is the vector component that gives directionality. And since they're parallel, it stays the same. Okay? So this essentially is saying a line which crosses this point, and we can make this random point, that would be that equation, because we have direction and a point that direction is crossing. Okay? Yes? We're done with this right now. This is how we write the equation of a line. It's 3 little equations for x, y, and z.
Did it ask for that?
Yeah.
What all did it ask for? Just like a vector and a point and the equation of the line?
If they ask for an equation of a line, that's what you need to find. A point and the vector component. So there's like 3, 4 different ways to do these problems. But if you're ever asked, if you're given 2 non-parallel planes to find the intersection of them, now you know what to do. Okay? Sort of always remember, if you're given a plane equation first, you always make it a normal vector. Okay? Like that pattern, they don't say it, but that's generally how it goes in the problems. Yeah. Because is equal to negative 2t. Oh, like originally,
Yeah.
we could have said x equal to 0, z equal to 0. I just chose y equal to 0, or they did. Yeah. Yeah. These numbers technically can be any points on the line. They'll always give you the same equation for a plane. Okay? Like those problems they did with point P and point S or something, and then they said check it with S and you'll still get the same. Do you guys remember that? Okay. So any questions on this overall? So don't, like, it's good that you guys are here, but this is not something that you can study in one night or in like a couple of hours in the evening. Or you can, but then you don't understand it. You just BS your way. So can we move on, or?
Let's go to many options of questions.
That's the answer.
Yeah, that's the equation of a line. So now objective 19 is given two intersecting lines, not planes, but we're given lines. Find the intersection point and the equation of the plane determined by them. 19. The answer is all three of these. That is how we write an equation of a line, okay? So I'm going to repeat this and you guys tell me what I need to find, all right? Given two intersecting lines, we have to find their intersection point and the equation of a plane, all right? What does equation of a plane mean? What do you have to find? The normal vector, okay? The only way to get equation of a plane is if you know the normal vector. So you already know that you need to find that. And then you can look at what you are given, but okay, let's do it. So when it says you're given the equation of a line, what are you given? Exactly. So you guys should know in your mind, you should understand that when it says equation of a line, it means three equations involving x, y, and z. Okay? It's not one equation or anything. So x is equal to t, y is equal to negative t plus 2, z is equal to t plus 1. Don't let this fool you when it's t plus 2 or something like that. It's still the same thing. Line 2 is x is equal to 2s plus 2. Y is equal to s plus 3. Yeah. Z is equal to 5s plus 16. Okay? And then I'll draw it quickly. Okay. The one here, it represents what? The I. Okay? It represents the direction for x. And then that goes for all of the ones too. They want us to find where they intersect. First thing they try to do is solve for t and s. Okay? You're given two variables and 6 equations. Okay? Actually, no, it would be more because y and z are different than that. Okay. But right now, looking at these two, since those are both x's, or yeah, so we can set them equal to each other. T is equal to 2s plus 2. Okay. You can do the same thing with the y's. Since y's are equal, we have minus t plus 2 equal to s plus 3. So 2, so the t's cancel out. 2 is equal to 3s plus 5. S is equal to a -1. Okay. And then t is equal to, if we put a -1 here, we get t, which is equal to 0. Yeah. Does anyone have a question? No? Okay. Since these are both equal to an x, you can make them equal one equation. Since these are equal to y, you can make them one equation. You could do it with z as well. So then you just solve for t and s. Since now you have two equations with t and s. Okay? So you could do all the different combinations, but general rule of thumbs that I think is true if you're given t and s, first thing you should do is find what they're equal. Like this. Yeah. Yeah. You do substitution or elimination. Yeah.
So this is the
We're trying to find, yeah, the intersection point and the equation of a point. But right now, we found what t is. So this is sort of just leaving this aside. Let's go back to that vector thing. Okay. This is an equation of a line. Okay. Without the point, what is V1? It's essentially parallel to L1. Okay. Because we don't have the information for the point. So V1 is parallel to L1. So then what is V1 equal to? I minus J plus K. Do you guys all realize how we got that? The A, B, and C components came from the A, B, and C components of the original line equation. And then just to understand it, since this vector is parallel to L1, okay? It's not L1, since we don't know it doesn't have a point component to it. What? Any questions? Yeah. So what is V2?
2i plus j plus 5.
Okay. Yeah, we could do one more thing. So that is V2. And since we did find what is t equal to, we set t equal to 0. What would the coordinates be for our point? 0, 2, and 1. We solved for s and t because we found out t equal to 0.
I mean, if you're willing to do that, though,
Yeah.
use the top to write the equation.
No. T could have been a 1 or a -1 or anything, okay? Since we found s is equal to -1, you can plug that in and get that values too. Okay. So if we, since s is equal to -1, 2 times -1 plus 2, x is equal to 0. -1 plus 3, x is equal to a 2. And, okay? No, we did need to know. We did need to know s and t to find the point. Okay? Yeah. No. But since t is 0, it makes it easier. Yeah. They could just. Oh, one thing I would mention, this exam, well, this is a 50-point exam, but these exams will be long and hard to finish. Like, this is a 2-page exam, but generally, yeah. So that's why I always do the ones that I can do, finish the exam, then go back. Yeah.
What was the reason for finding vector?
Because we have to find now the plane.
For finding the plane now?
Yeah.
So we have the point.
Yeah. So what do these vectors tell us? What can we use them for? Cross them to find what? The normal vector. And we use the normal vector for what? The equation for a plane. When t is equal to 0, we plug back it in the line. We could do with s equals -1. But, okay, so let me just ask this again. We have v1 and v2. What do we use them? What do we do with them? We cross them to find what? Normal vector. What do we use the normal vector for? Plane. And then since we have a plane and we have a point, that's the equation of a plane. Did that click for some people? Okay. So writing out the matrix I, J, and K. Does anyone want to say it? Hit, yeah, 1, -1, 1. And then you guys should try to do this in your head. It's -6i. Or if you don't want to do it in your head, write it out. Never like make a mistake on algebra. Okay. -6, -3, and a 3. Make sure you guys get those answers. Don't just write them down. Because by the time it comes to the exam, this should be second nature to you guys. Okay? Don't try to spend time like doing this and then like wasting time subtracting j or by mistake adding j or something like that. Okay? That's equal to ai plus bj plus ck. Or, you guys have it copied down?
I got a -3.
Isn't it? Should be positive. You block out these two. 1 times 1 is 1. -1 times 2 is a -2. but then you subtract it. Are you guys good with this? All covered? And I will erase it. So the equation for a plane again, we use that. I won't write it again, but it's -6 times x minus 0, because that's the point we found for x. Okay? Minus 3, y minus 2, plus 3, z minus 1, equals to 0. You guys, after this point, should do it very carefully not to make any algebra errors, because it would be sad if you lost like all the points because you made that mistake. You wouldn't lose all points, but you'd lose the majority. Yeah. So then you guys can do it, but the answer is 2x plus y minus z equal to 1. Okay? It's a positive one. You divide by a -3, so then it turns positive. But there's 2 more examples that we do need to get through. If you guys do need to leave, make sure you signed in, and I'll just keep on working. Can I erase this now?
Would it be a positive one?
No. It turns out to be a -3, and then you divide it by a -3, because that's what they have in common, and it turns to a positive one.
They got it.
Yeah. If you write what? Yeah, if you divide it by 3 and it'd be the negative of these. Like if you have -2x minus y plus z, is that what you have? It's the same thing, yeah. Yeah, so you have this equal to a -1, then it's an algebra mistake. So this would be a +6 here. This would be a -3. So it's a +3 on this side. You bring it to the other side, it's -3. Okay. Can I erase this now? Okay. Any questions, final? No? Make sure you guys all do the survey. But there is like a 90% chance this is the time the session will be held, because that's like the best time for me to do it. But I will look at the survey, and if like a Wednesday or a Thursday works better, I might do it on those days. Okay? So we are given 2 parallel lines, and we have to find the equation of the plane formed by them. Okay? Same as what? Yeah. Yeah. It's not the intersecting plane, it's the plane formed by the lines. Okay? Before we had So these lines aren't intersecting.
Can you explain that a little bit, planes formed by lines? Is it just basically if you filled in the gap with an area and slice it all the way around the line?
Yeah, it's like, so you have two lines intersecting. This would be the normal vector. I sort of imagine it as a line right here or something. I'm not sure if I am correct.
As in line slicing through the middle of them, or it's perfectly
Um,
normal plane?
Oh, sorry, yeah. It'd be like
Yeah, okay.
that.
That's what I was.
Do you guys get that?
It's like you just rotate one all the way around.
Yeah.
and you-
It's like the plane that they're on, essentially. So for this one, we have two parallel lines. Make sure you guys understand like how to imagine this in your mind, okay? Don't just skip over that. Again, lines go on forever, so if you do put arrows, make sure you put them on both sides.
We take them off.
Probably not. Because eventually they show vectors. So these are the two lines that we have. Let me write down the equation. X is equal to 1 plus 2t. So they did this in class, but I'm just going over them. Just to let you guys know. Y is equal to minus 2 plus t. Z is equal to minus 1 minus t. Now these are parallel, okay? That means a different point value, but the same direction component, okay? So then y is equal to 1 plus t. Z is equal to 2 minus t. Okay? When I say like a point in space, I mean like this point that this line is going through, and then the direction component is the vector component. So what would the vector be? Two I plus j minus k. And that's parallel to L1 and L2. Okay? To find the equation of a plane, what do we need? A normal vector, okay? To find a normal vector, we need how many vectors? 2. So we need to find one more vector on this plane, okay? So we know 2 points, the point components of these two lines already, okay? So since we know 2 points on the plane, we can find the equation of the vector formed by those 2 points. Okay? So then a vector going on the plane would be P1, P2. Okay? So now we know a way to get 2 vectors that if we do the cross product of, we can get the normal vector. Did that click for some people?
And you want to do P1, P2 to B1, right? Or right hand.
B2.
Vector goes up.
Yeah. Yeah. So we can set t any value, but for, to make it easy, we make it t is equal to 0. So then what would P1 be? -1. 0.2 would be 312.
Will they have any questions where they'll give us like one vector and then the plane, they won't tell us what the other line is, and they tell us to find the line equation?
Like they tell you the vector?
Yeah, like they'll tell you just V1, and then they'll tell you normal, and they'll tell you the plane and line 1. They won't tell you line 2, and they'll have you find the equation.
See,
No, it would have to
not
be
really.
simple as-
When you're saying normal and the plane, you're already like, you get that information from the plane, essentially. So just, yeah, they won't, just the 3-4 different ways they show in objectives, that's the way to do them. But they're not going to make it overly complicated. They might next unit. I don't remember what that is. It's something with this stuff. Okay. Yeah. So P1, P2 is what? Remember, P2 minus P1. Okay?
Right.
Plus 3. You could have done P2 to P1, but then you had to find the right vector for that. Okay? Like if you did label this as P2, P1, then you're going to P1, then you would need to subtract 1 minus 3.
Yeah.
So make sure you keep it consistent and label it correctly. Yeah, it changes the sign, but make sure you name it correctly then.
So it doesn't matter which way you do
Yeah, but just, yeah, make sure the name is correct on it. So the normal vector is equal to the vector that we found, crossed with P1 to P2. Okay. And do you guys want me to write out the matrix and stuff? Okay. IJK 1 negative 2 1 negative 1, and then 2 3 3. That's equal to the normal vector, which is equal to. Make sure you do it in your head and definitely get these answers. 6I minus 8J plus 4K. Okay. What? No, that's fine. Are you? Do you guys have a copy down? Yeah. Yeah. Okay. Did everyone sign in? Where is the second sign-in sheet? That's. Are they both here? Yes, they are.
Does it matter whether you cross P1, P2, like, does it matter to switch it? I know it'll like make it a different answer, but like, will your answer work out?
You have to wait 1 second then. Yeah, but then it depends. It changes something else. Okay, so I'll show you guys what changes in a second. Okay, so the equation for a plane, since we used P1 to P2, the point where the vector and the P1 to P2 cross is at point P1. Okay, so we have to use P1 when we write the equation of the plane. Yeah. That's when you have. No, you have to use P1 on this. That's like in a different way. That's when you have T and S, you can use whichever one to find some equation. But for this problem right now, it'd be 6 times x minus 1 minus 8 times y plus 2 plus 4 times z plus 1 equal to 0.
Why do you use P1 instead
Because in this one, it does matter. We went from P1 to P2, right?
of? Okay.
So then the point where this vector, we started it at P1 essentially. And that's where we labeled the other vector from.
So if we
But
went- so if we went from P2 to P1, we did that vector,
then you use P2.
okay. They should have told us.
They said it for, I don't have it written for this one that you can switch them.
You're supposed to, I'm supposed to prove it using the other one.
That's for the next problem where in the next problem you are given 2 points, but then it's only one line. Then you can do it for P or S. You can try it and then we'll see. Does someone want to try it with other point? Did someone try it with other point?
Just do it.
Well, for this one we get 6x minus 8y plus 4z equal to, when you simplify it, so let me read. 3x minus 4y plus 2z equals 9. But if I were to do it, it'd be,
X minus 3.
yeah, it'd be x minus 3. So let me just do it quickly then. It's a good question that we.
That's the same thing.
It gets the same thing?
Yeah, that's the 4z plus 2.
It does give the same
Positive 8, and subtracting 8 and adding 8.
So yeah, it does give the same answer. I don't know why in my notes I don't have
That's
that.
not just a bizarre problem, right?
No,
No, no.
it's because they're parallel, so it's exactly the same.
Yeah.
It's the only thing
So-
that the focus are doing is changing where it starts. It doesn't really
But actually, your signs would be different on this answer. This would be a negative. No, never mind. Just go with it.
Yeah.
That's just right now.
Yeah.
D1.
Okay, sorry about that. You can use whichever point. Normally, just stick with P naught or P1. Okay. Any questions on this?
What was this question asking for?
This question, we were given 2 parallel lines, and we had to find the equation of the plane.
Okay.
So just to recap it all, since these are parallel, we found B1 from the lines, okay? And it'd be the same for both of them, but we need 2 vectors to find the normal vector. So we did P1 to P2. That led to the normal vector, which always leads to the plane. And it depends on what you call the normal vector, okay? Because in the other one, the normal vector is the same as the line, so then you don't go to the plane from it.
The normal vector really perpendicular to the plane.
But it can be in the same direction as the line.
The piercing point is the point of the normal vector.
So are you guys good with this problem? Who is not good with it? Okay.
Yeah, I'm just like, this, it just seems like all we're doing is finding another vector, like, I don't see how normal, like,
So we knew this vector from the line equation. We found this vector from P1 to P2. The normal vector is the cross product of them. And then once you have a normal vector, the plane perpendicular to the normal vector is the plane that we want. And in this problem, yeah, it is. So then we use the values for I, J, and K for it. So it's essentially looking at what you have and then trying to find whether, if you're going for the plane equation, then try to find two vectors that you can use to get the normal vector. Okay? And then in other problems, like the distance one, it's a bit different.
Is it wrong to say that in order to find a plane, you have to have three different dimensions defined, and one of the ways to find the third dimension is the end vector. That's the way I think.
Okay. I just look at it as you need to find two vectors, and whichever method you use to get the two vectors. If whatever works for you. For objective 21, do you guys want me to continue or? Okay. Yep. Objective 21, give a line. If you're given a line and a point not on the line, okay? And you have to find the equation of the plane. So first thing that should go through your mind, you're trying to find the equation of the plane. So what do you have to find? The normal vector, okay? So your goal should always be now to go to the normal vector. Since we are given the equation of a line, what does the equation of a line lead to? It leads to a vector with the I, J, and K, okay? But that's just one vector. Yeah.
If you've got the line, could you just create a new perpendicular line to that going to the same point and then take the unit vector or the normal vector when that goes to the S point?
You're given that point, okay? Yeah, so that's essentially what we're doing. Because we've used the line to, we're trying to find the equation of the plane.
Oh, I thought you were trying to find the distance.
No, we're not there yet. So that's a problem after this. Okay. X is equal to 2 plus t. Y is equal to -3 plus 2t. And then b is equal to 1 plus t. So what would the vector equation be? Yep. Now, do you guys all know that automatically? Okay. That's fine with me. Now we need, so let me draw this quickly. The point that we are given is 1, 2, -2. So we have to find a point on the line. So what's the easiest way to do that? T equal to 0. So the point is 2, -3, 1.
So we find the point on the line that is what?
So we're given this point, but it's not on the line. We have one vector. To find a point on the line, we can always set t equal to 0 and take that point. Okay? That's like saying when time is equal to 0, what would x, y, and z be? Because this line varies with time. Okay. Do you guys all get that? Ignoring the time thing? Because I mean, it's true, but I don't know. You guys don't need to pay attention to that. Okay.
What dimension is
It's the fourth dimension. Okay. So going from P to S, what would our vector be? 1 minus 2 plus 5j minus 3k. The normal vector is a cross product of them. One, two.
1, 2, 1?
Yeah, 1, 2, 1. -1, 5, -3. Make sure you guys do it in your head or paper and get these answers. Plus 2, -11i plus 2j plus k, 7k.
Are you writing those vertically for a reason? That's something that just easier for you to.
There's not enough space to write.
Okay. You do the same thing.
And then what is the next step after this? Exactly. We have the A, B, and C. We have a point on the line. Then we have the equation of a plane. And then it does work with S as well, because they'd be on the same plane. Do you guys want me to write it out? Yeah? No? Okay. Yeah.
Write the -1, 5.
Going from point P to point S.
Oh, yeah.
-11 times x minus 2 plus 2 times y plus 3, right? Plus 7 times z minus 1 equals to 0. And then make sure you guys solve it correctly. That's equal to 11x minus 2y minus 7z. Yeah. Positive 11x equal to 21. Solving. You could have minus 11x and then, yeah, both are fine. And then you can do it with s, and then you'd get the same answer. So is this like making sense in some way? Like you can go over it, but the idea that if you find the normal vector, you can go to the plane equation if you have a point on that plane. That should make sense right now. Then tonight, when you go over it, it should make sense that two vectors lead to a normal vector. Okay. So now we can do the problem finding the distance if you're given a point and a line. And then you have to find the plane and the distance. So let me redo it. Okay. No, in this one you're given, you have to find the distance from a point S to a line. That's all you're told. Okay? So can I erase this? Okay. And if you have to leave, you're welcome. Okay. So this is L, that's point P. And we have to find this distance. We are given that S is 1, 2, -2. And L is equal to x plus 2, or x equal to 2 plus t. Y is equal to -3 plus 2t. Z is equal to 1 plus t. Okay. The normal vector is the vector that is perpendicular to the plane. In this case, the line is perpendicular to the plane. Okay? So the line, the normal vector is the vector parallel to the line, essentially. So the normal vector is the vector that we get from the line. So normally we have a vector on the line, right? In this case, it is the normal vector since that's also parallel. So they're equal. And what would that be? I plus 2j plus k. Any questions on that? We're trying to find the distance from S to D. Okay? Sorry, P. Yeah, D is the distance. So right now we need to find the equation of the plane first. Do that ask?
Isn't the same?
It's what you did in class.
And then like,
So they tell you the plane is going to be perpendicular. That's why we can say the normal is the vector. Okay? Yeah, the plane and the line are perpendicular. So since we had the vector, and we have a point on that plane, it doesn't matter whether it's P or S, it's a point on that plane. We can find the equation of the plane. So this would be 1 times x minus 1 plus 2 times y minus 2 minus, is that right? Y minus 2, yeah, plus 1 times v plus 2 equal to 0. We had a normal vector and a point on that plane. That's all we need. It doesn't need to be point P or S. Since we know S already, we can just use that. So then x plus 2y plus z is equal to 3. Okay? Now we know the equation of the plane and S. That tells us the point where the plane is intersecting the line, essentially. Okay? So, yeah. That's the piercing point where P intersects the plane, or piercing point P where L intersects the plane. Okay. So right now you have this equation, and you have the top three equations. Okay? What do you guys think we should do? Simplify. We have 4 equations and 4 variables. The easiest way to simplify this is by substitution to find t. Okay? So right now, what we're trying to do is find point P. Okay? We have found the plane which intersects the line. Okay? So we have the equation for the line and the equation for the plane, and we just sub it in. So we have 2 plus t, which is for x, plus 2 times y, and y we know is -3 plus 2t, plus 1 times z, which is 1 plus t, equal to 3. Any questions on that? So we get essentially 6t, yeah, 6t minus 3 equals 3. T is equal to 1. Don't forget the arrows. So now we know when time is equal to 1, that's the plane that is the same plane as point S on the line. Okay? So then what can we, since we know t is equal to 1, what can we use that to find now? The point of x, y, and z. So when t is equal to 1, what does x equal? Yeah, x is equal to 3. Y is equal to -1. And z is equal to 2, if you guys can read that. We just plugged in t for x, y, and z. So I can write it x is equal to 1 plus 2, that's equal to 3, and then whatever. Yeah. I know this seems like a lot, but
So
yeah,
very visual.
I learned this yesterday or something. I reteach myself stuff. 'Cause, I'm not gonna. And I don't pay attention in class, so. Yeah.
I don't know.
Okay. You guys should pay attention in class, though. Because if you rely on coming here or studying the night before, it's not gonna work. Yeah.
And then they act like that we understand it, that they don't really know that we're just
Yeah.
like accepting what we say.
Their flipped class model is extremely effective.
They're gonna try it when you guys are in DE.
On what?
Flip class.
That's what they're doing now.
What's flip
Half the stuff we do is online.
What's flip
No.
It
What
is
they mean by-
songs as a video.
What they're gonna do is they're gonna completely make DE video, So you have to watch the video the night before, like in physics, and then in class they'll give you a little quiz.
No.
Yeah.
That's
They're thinking about doing that, and it's gonna probably
failed miserably.
99%
That's a
happen.
wonderful idea, because it basically means that the professors don't actually have to teach.
Because then they can just review the material like what I'm doing right now. Essentially, I'm reviewing the material again the second time.
And it's almost like if they did normal teaching, you wouldn't need to stop.
But they have so much stuff that they can't like slow down though. Okay, going back to this, do you guys get how we got the point? And then you use the distance formula from S to P. I'll quickly write that up here, and then you're welcome to leave, and thanks for coming. But if you want me to write it down, I'll write it. And then if you guys have any other questions, you can ask. Make sure you guys have signed in. If you're If I have that written down correctly, that's the square root of 29 length. Give what? They'll give you diagrams. 1 second. No, they will not give you diagrams.
Well, maybe just throw some
It's good to really understand this stuff, but on the test, if it's hard for you to imagine it, say you're given a plane equation, okay? Write down the normal vector equation because it'll be worth some points, okay? And then try to work your way through the information that you're given, if that made sense. Or do as much as you can and hope for points, essentially. Like, write down the normal equation, whatever. And then I will do more problems on the exam night. But yeah, I'm gonna try to upload them tonight with a review. And this video will be uploaded as well. Yeah.
Thank you.
Yep. Thanks. Hopefully, if I feel like doing it. I definitely, okay, how many of you guys actually do the practice exam before you come to the session?